Good morning, children. Once again, we are here to discuss the refraction of light and a refractive index. As already we know the properties of light. Light has so many properties. Among them, there is one property. It always travels along the straight line in the same medium. Here we must know the term medium. Medium means the substance through which light travels. In this room, the light is traveling from the bulb to every other point through air. So, air is the medium. If we see anything through water, water is the medium. Like this, any substance through which light travels is known as medium. When light travels through the same medium, it travels along the straight line. There is no deviation in the path unless we put any obstacle on its path. But if the light ray changes its medium means as it is traveling along the straight line, suppose it is traveling along straight line like this. Up to this, there is some medium presence. After this, if the medium changes, the medium may be anything. It may be water, it may be glass, or any other substance. When it enters, suppose this is the surface which separates the two media. Here we have one medium, and this is another medium, medium 2. If it enters from one medium into another medium, if the path of light changes, if it deviates from its original path, this is the path along which light travels. If the medium does not changes, it travels along the same straight line. As the medium changes, on entering into another medium, definitely the path of light changes in some condition. What is that condition? That we will discuss later on. Here we are discussing that whenever light enters from one medium into another medium, the path of light changes or the light deviates from its path, then we say that the refraction taken place. So the phenomenon refraction means it is the phenomenon of bending of light, deviation of light when it enters from one medium into another medium. Whenever light enters from one medium into another medium, if the light bend from its original path, then the phenomenon refraction takes place. So it means refraction is referring the two media property. It is not the single medium. It represents two media property because it travels with some speed because the light is traveling. Its speed is, its velocity is utmost. Its velocity is utmost in vacuum. In vacuum, the speed of light is utmost, that is 3 into 10 power 8 meter per second. This is in vacuum only. If it travels in any other medium, then it will not travels with the same speed. Because of the presence of particles in that medium, the speed changes. Obviously, the speed decreases. So, the speed of light changes when it enters from one medium into another medium. Because of changing the speed of light, it deviates from its path. So why does the refraction of light takes place? Because its speed changes when it enters one medium into another medium, then the refraction takes place. So we can say the cause of refraction. Why does the light refracts? It is because the speed of light changes. Now, the light, it travels with this speed, and the light is also having a property of wave. It is also having a property of wave. In class 9th, we discussed about a relation for a wave, that is v equal to nu lambda. This relation you could remember. Velocity is equal to frequency into wavelength. And this relation is also applicable for light. It is also applicable for light because light is also having the property of wave. Now, in this case, to represent the speed of light, we use the symbol c equal to nu lambda. This is unique property because this velocity is unique for the light in vacuum. That's why we use the symbol c equal to nu lambda. C represents the velocity of light in vacuum. Velocity of light in vacuum. Then how do we represent the velocity of light in any other medium? That is with v equal to nu lambda. This is for vacuum. Okay. Here, if the light enters from one medium into another medium, its velocity changes. And what else change? Along with the velocity of light, the wavelength of light also changes. Then what about frequency? Frequency, it is the basic characteristic of light, of any particular wave. The basic characteristic of any particular wave remains constant, even though it changes its medium continuously. So, on changing the medium, the frequency remains constant. It remains constant. But the velocity and wavelength both are changing. So if it is constant, then velocity, it is directly proportional to wavelength. In vacuum, its velocity is utmost. On entering into another medium, its velocity obviously decreases and wavelength also decreases. If light enters from vacuum into glass, vacuum into air, vacuum into water, then the velocity definitely decreases, so the wavelength also decreases. Now we must see how does the velocity of light changes in vacuum and in air. In vacuum, nothing, no particles present, in that the velocity is utmost. Then coming to the air, velocity of light and air. Air in which very small particles present. So on entering from vacuum into air, the velocity of light decreases slightly. It is slightly decreasing. That's why that change of velocity of light from vacuum into air is negligible. That's why we consider the velocity of light in vacuum and the velocity of light in air are nearly same, nearly equal. We do not differentiate the velocity of light in vacuum and the velocity of light in air. Now coming to this, as we know that I told earlier, the velocity changes, then the path of light changes.